is it that you make, so you will have to visit every node anyway, because you have to find out the value across all nodes, and then you make a priority queue of it.
Can you explain this on example 1, how you're going to use a priority queue?
So what I'm thinking is we have to obviously look at all the nodes, and then
Okay.
and let me understand the problem correctly. The smallest value is 2, and the second smallest value is 5, right? So this is across all the nodes.
Yeah, this is the smallest value in the entire tree.
So we may not need to look at all the nodes. We may not. So what if we do a BFS starting from the root and just when we stop when we find any value other than the root? Can we, because the if the like as per the explanation, just let me know if I have misunderstood this. If we say that we start at the root with a value like 2, we know two things: that everything else in the tree is either greater or equal to 2.
Yep.
Now, in the on the next level, either out of those two values, if they are 2 and 3, then our answer is 3, because it is the greater than 2 and it's the second value. Then now, if
Okay. Are you sure about that?
that's what he said. He wants the second minimum value in the set, right? And the first minimum value would be 2, the second minimum value would be 3, and hence 3 is the answer.
Another subtree could have 1 as a child.
Well, that's not possible.
Yeah.
Because root.val is going to be equal to the minimum of both.
Root.val is minimum of root.left and root.right.
For every node.
So we know that the parents' children, one of them is equal to the root. And it is the smaller one which is equal to the root. The bigger one can be, the other one can be equal or it can be greater. If it is greater, we've got our answer. If it is smaller, then we need to go further to the next level and do the same thing. Now, coming from that, if we did a BFS, then we basically will use a queue and first of all put the root inside, and then we take that out and we put the next 2 in there, and then we take we go on in that way till we find something other than a value that is different from what we had in the root, right?
Okay, I'm not sure that that's always going to work.
I think I missed the part where the current node's value is guaranteed to be the minimum of the children.
Yeah, it'll fail. It'll fail when the left, if because it's from the left that we keep putting in the BFS, right? And it may happen that it's on the right hand side that it is smaller.
Yeah. So okay. So first, it's important to, like, the interesting thing about this problem is that you have this property, right? You have that root the val equals the minimum of right. This is the most important property about this tree, right? Okay, so Sandish's approach, so his proposal is that, okay, if the tree looks like this, okay, you have something else here, like, and Sandish's approach is that he's going to do a BFS, right? I assume that, everyone's familiar with BFS. So he's going to do 2, go to 2, then go to 2, then 4, then he's going to return 4, because 4 is the first number that's not equal to the root, right? But we can see in this case that it's wrong, because 3 is actually the second smallest, not 4. Okay, any other proposal?
In this approach, if 3 were in 4's subtree, if it was 2, 4, 3, 4.
Possible? Like root.val is equal to the mean of root.left val, root.right val. How can 3 be in the 4th subtree? Right? If you have 3 here, then this one should be 3, right? Similarly, if you have something else, you have a 3 here, then this one is at most 3, which means that this one is at most 3. Right? So if you have this condition 1, then you're guaranteed that root is going to be the smallest level, right? So, and nothing inside this tree is going to be smaller than the root. Other things may be equal to the root, but you cannot be smaller than the root, right? Then similarly, in this subtree, nothing can be smaller than the subtree's root, which is 2.
So what if this was 2 and then 3? So what my question is, like, what if right is smaller? So if this was 3, the 2 and 4 at the second level, what if it was 3 and 2? Not like this, but reverse.
Sure.
3 and 2.
But there's no difference between the left and right here.
Yeah. So now, but if you do
but this is not possible because 3 under that 3 you cannot have a
BFF.
2 then. Yeah, and you cannot have a 4.
Yeah, I mean the third level I didn't talk about. I was just trying to think out loud if we have such a tree. If we did a BFS, BFS is usually like level wise, right? You'll go from left to right, right to left. So if we did that, would we miss this case, or is it not possible? I see. So basically, what you're saying is that the root is guaranteed to be exactly the same as either the left or the right, because it is minimum of those two. So it doesn't matter where you start from. Basically, anything that's bigger can be considered the answer for the next bigger. Okay.
Yeah.
Okay.
Yeah. So we know that the root is definitely the smallest, right? There's no doubt about it, right? So now, if the root is 2, then you know that there are 3 possibilities. Either the left is 2 and the right is greater than 2, or the left is greater than 2 and the right is equal to 2, or both are equal to 2, right? Now, okay, so let's think about the 2 cases, right? So if the root is A, okay, then B and C. Okay, let's think about the 3 cases. First case is B is equal to A and C has to be greater than A, okay? Or B is greater than A and C is equal to A. Third case is B is equal to A and C is equal to A. There's no other possibility, right? Okay, so in case 1, where would the second smallest be? Well, the second smallest may be C, right? So in this case, C may be the answer. D is not necessarily the answer, right? Because if B has
recursive, so the answer is the minimum of C and the recursively the function applied on B.
Yeah. Okay. And our second B.
Okay.
Okay. Good. Then I think this case is symmetric, right? So it's going to be the minimum of B and the second C. Okay, so if they're both the same, what would the result be?
Minimum of the second smallest of this second smallest of them.
Good. Okay. Who wants to try this one? Anu, do you want to try this one?
Not really. Not at this one. Just trying to grasp the concept yet.
Okay. Which part are you not understanding?
On the second smallest B, right, or C, right? Like, no, can you give me an example of it? Like, no, so.
Yeah. Okay. So if A is 5, okay. So in scenario 1, you can your tree can look like this,
Okay.
right? So what is the second smallest here? The second smallest is 7, right?
7.
So you're comparing 7, which is this one actually, second smallest of B, right? With C is 10. You're comparing 7 and 10. You're finding the minimum.
Okay.
Does that make sense?
Yeah.
Okay.
Yeah, one clarification. So now if it is null, that means nothing is there. Suppose we have 2 and there's no left child, no right child. What are we doing? So
okay, you're talking about a leaf node.
Yeah, a leaf node. Yeah. Because if we do -1, then that will become the minimum. Problem is this.
Yeah. So what should you do in this case?
So infinity is lost a big number is what I'm thinking.
Okay, so maybe we do infinity, then finally we check if it's infinity. Then we
max or something like that. But that's a good point.
Yep.
Okay. So in this case, our goal is to find the second minimum. I think we will have to write another helper recursive call for this. We can't just we can't just return this. So
is it because of the infinity thing?
It's because of I think special case. I can also do int.max in this case. Can I use the same method?
Yeah, of course.
Okay. So find second minimum value, like you said, we could actually do a minimum recursive value and the current value. Actually, we can use the same one. You're right. So this can itself be the recursive call. So if root is equal to null, then like we said, we can assign it. This can be our base case in that case. And this default can be int dot for integer dot max value. Now, for us, it shouldn't matter if it doesn't have one leaf, like going by the previous examples. I think that's not needed, as long as we are handling the base null case, or the yeah, so this is fine. So if now there were three cases that we had discussed, right? We had discussed that if left is greater than, say, root, and root is equal to right. Okay. So in this case, and what would we call it? We'll call it second largest or second biggest, second minimum, second min, and yeah, this would be second min right candidate. So let's say this would be a math.min of whatever it is, whatever is greater than, so left. So we'll do root.left and find second minimum value wherever it was equal. So it was equal the right. And then the other case would be where the right subtree is greater than the root value and left is equal to root. Second min left is equal to math.min, same thing, root.right, and we find second minimum root.left. Great. And then the third case that we were discussing was left is root is equal to right. In that case, we will second min root, I don't know, let's see, math.min, we just have to do a minimum of these. But this is only if, yeah, I think so. I don't need to define these as separate cases and combine them later. I can totally just do this. If root is equal to root dot right, and I don't know if this has a value. Yes, root dot val. Okay, so the root dot val is equal to root dot right. Then I can do this, and I can do just define my second minimum. Oh, this is also the return value, by the way. We can just do return is equal to root dot left and this. Okay, and then the same thing here. If dot val is equal to left in this case, and again return is this. Okay, so else, and then else return is equal to this, and then finally I can return the return value. So I'm covered in the null case where I just returned the max, and that would get compared against this one. But wait a second, if I'm doing that, both of these will come back as max and max. So I'll have to check if this comes back as a max. Like there's a chance that this will return a max, and and this already has a value. So I shouldn't be actually traversing down. They already have values, leaves. So I don't need to do this actually. The max value. I can just do, if this is a leaf, this can be my base case. So if this is null, wait a second. This can be fine. Okay, let's leave it there. But we can also have another base case, and we can say if root dot left is equal to null and root dot right is equal to null, then we return whatever value it is. So we return
clarification.
Yeah.
So if it is going to have only one child, suppose left is null, but right is not null, then the right will have to be equal to the parent, right?
Is that possible?
Because it says that it's the minimum of the two.
But only if it has two children. I think the question says.
No. Yeah, exactly. You should reread the problem statement. If the node has, where each node in this tree has exactly 2 or zeros.
Oh, okay. Yeah.
So this is the 0, 1. Okay, so this is another base case. these two are our base cases. This looks okay to me now. This would ensure that we are evaluating nodes that have, and I don't need to check if this has one node only because the problem calls out that it can only have 0 or 2. Okay, so let's quickly run it and see for one. Root.val. Root.write.val. And okay, so I will have to do this here.
In the method, you're sending the root, right? Not the val. You need the node.
Yeah. Here. Okay, so this is one. Wrong answer. -1. How did I get -1? Oh, expected is -1.
Yeah, you're returning 2.
I see. And because it was part of the problem, I see. Okay, so problem was that if there was no second minimum, so I somehow have to know that there is a second. So okay, so at the end of it, if I don't find anything, if my return at the end of this computation, or maybe this is why I need to find a different method, because this is recursive, right? Like in the middle of my recursion, I don't want to set it to -1. Okay, so this is the reason why I probably need to do this in a second method. Do you agree? Do you guys agree? Okay.
Yeah.
And then call second min, pass it root, and then check here if ret.val, ret is equal to root.val, then return -1. Hopefully. No. Okay, fine. Okay. Input 2. Single node didn't pass.
So I think that's you're returning the int.max or something.
Oh.
Right.
So why is that though? It should be checking here. So if I return this and this from both places, I shouldn't even be traversing those. I shouldn't be traversing. I should just be returning these. If so this never gets activated, does it? So for if root itself is a leaf, and then we come.
Well, then your line 36 would return integer.max, right?
Why did I do root.left here?
Actually, no.
Yeah, no, this is correct. Root.left was wrong. Okay, now it's correct. -1. Sorry about that. Let's quickly check. Expected is 5. And the output is -1. So if I go here, look at this. Where is this -1 coming from? Red is equal to -1. Okay. But there should be a value in there. If root is equal to null, then return this. Root.left and right is equal to null, then return root.val. In principle, it looks the same as what we had discussed. Oh, I'm not recursing correctly. The old method name.
Yeah.
Okay. But I have to find the second minimum, right?
Yeah.
So from the top level method, I shouldn't be passing root then, because this is really returning the minimum, isn't it? It's always returning.
Well, it is returning the second minimum. It's not returning the minimum.
Isn't it always returning minimum? Because if this is, yeah. So then.
Well, if you wanted to return a minimum, you should just return the root.val, right? Root.val is guaranteed to be the minimum.
True. Then why is this happening? I may need to add log messages to find out. So what I expect out of this is that it would come to 2.
Actually, I think we can make the test case even simpler. 2 to 5. You don't even, let's just keep the first 3 items. I think it will still fail. Yeah.
Yeah. So 2 to 5 failed. 2 to 5 because, let's see. So it would enter here, and then root is not null, and this is not true. So it would come here, and root.val is equal to root.right.val. In this case, what is happening really? Left.
No.
So left case will get activated, and then math.min of root.right.val. So root.right.val, which is 5, and second minimum of root.left. So second minimum of root.left will definitely give. This is null, so it'll come here and return max value.
Wait. Hold on. So root.left now is 2, right? So second min of root.left will give you 2.
2. Okay, so now it'll come in here, and it's a leaf, so it'll return 2. So this will be 2, and this is 5.
I think that's the problem, because second on line 53, the second min of root.left shouldn't give you 2, because this root.left only contains, this subtree only contains one value, 2.
Yeah.
Right. So if a tree only contains one value,
and that is equal to
shouldn't
root.
Be.
Yeah. It should be -1.
It should be -1.
No.
Okay. Well, if it is -1, then your line 53 would guarantee to return -1.
Yeah. So
what do you want it to return on line 53?
On line 53, this should return 5.
Yeah.
But I can't. Exactly. So I want it to return max. So if whenever it is different than root.val. Okay.
This one should have been max. This root is left, and left is null, and right is null.
Yeah.
Max of root.val?
No, just max it. Just integer.max value.
Okay.
After that, you also, there's a catch.
Anyway, okay. Let's try. Integer dot max value. Okay. So now if we try.
So because then, so I got to this point, and I had to make them all long to evade this problem.
Okay.
So, no, not this problem. Not this. This is a different.
Okay, this is a different one. So, if the input is just a single node, and I return this, and then this is coming in here, that's not correct. So if this is
so your base. Yeah.
I think your base case is not needed. The 33 one is not needed. Just comment, if you can comment that out. Just
this
comment
one?
out
The root equal to null?
Yeah.
Okay, let's try that out. So I don't even send it if it is a leaf.
Yeah, but still on line 21, you need to fix.
Yeah, so if this is root.val, or my return is equal to integer.
I think it should be only the second case. The first one is not needed.
Yeah.
First one is because it's not getting set anywhere.
It's not going to be, yeah.
Okay. All right, and now let's try wrong answer. 2 to 2. Skewed tree. Y is 2 to 2. No, 2 to 2. It's the same case 2 to 5 that we had solved just now. Okay, so 2 to 2. So in this case, it would come in here. Root.left, this will not get activated. Root.val val is equal to everything actually. Okay, so yeah,
No,
no,
actually,
this had to be there. See, this had to be there. Root dot return is equal to root dot val. Now I think probably going to be fine. Let's at least try this one and then submit.
Okay.
So I think we're not fixing. There's one more issue. So if you scroll down,
yeah,
right. So we said, okay, there are three cases. The first case, if the left child equals to the root and the right child is greater than the root.
right.
And but on line 47, you are saying, okay, if the right child is equal to the root.
Yeah.
But also we need to say that the left child is greater than the root.
Yeah. Okay.
Right? Yeah.
So root dot right dot val is greater than root dot val, and similarly.
Actually, I checked only the greater conditions and.
Did it work for you?
Yeah, I've got it through.
Okay. Then yeah, if this doesn't work, then okay. Let's.
Yeah. Okay.
Okay.
So there's one more catch in this problem which I made. I can share my code.
Yeah, please.
Is it the long thing?
Oh yes, it is.
Yeah, long thing,
int
exactly.
max. Okay, somebody made a test case out.
Because we made a special use of the int max, right?
Yeah.
So yeah, this is.
But somehow they also their input can contain.
Yeah.
Exactly, their input contain.
So yeah, so you need to.
I made all of them longs.
Yeah. Okay.
That's it.
Yeah. Let's take a look at Sandish's code. Yeah, Akanksha, your code is almost correct.
Yeah, let me try.
Yeah.
But this is also a bogus test case. Like they have to give us some value of something that's not present. So yeah.
Well, so that's why if they give you if they don't give you, if their range is your range, then you need to increase your range by making everything long, right?
Yeah. They've given actually 1 is less than equal to no dot val, less than equal to 2 to the power 31 minus 1. So yeah, converting it to long is probably the right thing to do. Okay, we can wait and see. Yeah. You can go ahead, Sandesh, and share.
Yeah, I shared. Can you see?
Yeah, I can see it. Sandesh, do you want to walk us through your code?
Yeah, so actually it's the same logic, just maybe less lines. So the first case basically is both are null. So in that case, long dot max value, and we know that it won't collide with any real. So if the left, the difference was that I didn't do instead of checking the equal to, I said that if this one is greater, then the other one must be equal.
Yeah.
So I made use that actually made it look a little simpler, and the rest of the logic is pretty much the same. If they left and right, and then in this case we do both min, and over there we basically check for if it's the long dot max value then -1, otherwise it's the integer version of whatever we got. Okay.
Good. Anu, do you have any questions about Sandish's code?
No, I have good understanding on that. Yeah.
Akanksha, did you make your code work?
Sorry, I was muted. So this was the exact problem, the long and the int one. That was the last remaining test case, and then I was finally able to get it in. I
see. So actually, now I'm curious because I don't.
Yeah.
If you scroll up, so maybe can you remove on line 21? Can you remove this red equal to root of val?
Okay,
I'm not sure if that's needed.
Because if all the values are the same, it is needed, right, for this test case. Let me show you. So if I change that and it's just 2 or 2 to 2, for instance, yeah. How did it? Oh, because this is disactivated this one. Okay, so let's try 2 to 2.
Yeah. So I think it's going to work.
But how? Because of this condition, so it was failing because of this, maybe. Okay.
No. So okay. So yeah. So if both children are the same, right, then you're going to recursively find second on both roots, and both roots are going to give you -1.
Yeah. So earlier I was, in case of 2 to 2, I wasn't activating this. I was, because in the absence of this.
You didn't have, because you were only checking for the equality, but you're also checking for the.
Like I think Sandesh had a good point. Remove this and just check that.
Yeah, this is not needed.
Okay. Sounds good. I think that sounds good to me.
Yeah. So if both give you -1, then if you scroll up, then your helper method will give you -1, right? So, which means that on line 26, it's just going to return you -1.
Say that again.
So if your both children are the same, right, then find your second mean. If you call second mean on both children, they're both going to give you -1.
Right.
Right. Then it doesn't go through line 21, but it does
all.
go through line 26, and it's just going to give you the result, which is also -1.
Okay, so you're saying that this is also probably not needed.
No, this is needed.
This is needed.
Yeah, this is needed.
This is for that case. Okay. Okay, so this looks good then.
Yeah, this is good.